All right. Good morning, good afternoon, good evening. I guess like you might be listening in from all over the world, I guess, because this is a huge crowd and I'm really happy to be here. My name is Yogi. Let me just go ahead and quickly, Sir Mao did a great job of introducing me, but I'll just tell you a little bit more about myself. I'm a principal solutions engineer at Yugabyte and I'm Yogi. So I guess like you could like sort of relate me to a yogi doing yoga or a yogi bear, like depending on which genre you come from. I live in Singapore, and as Samau mentioned, I work with customers and partners across the region in South Asia, Southeast Asia. I'm a software engineer. I was like churned out in late 90s, I guess, as an engineer. And I do have a lot of design experience and development experience in FSI, telco, and retail kind of spaces. Now, you can actually reach out to me on my Twitter handle and my blog as well. But yeah, absolutely, for anything related to Yugabyte, you just go out to your favorite VST personnel. So before we sort of move on to the resiliency part of the presentation, I always like to sort of highlight the very basic parts, why we are here, right? I mean, what are the objectives that we are trying to achieve as a business? So obviously, every time we are talking about anything to be done in the technology, it should always go back to the core ideas, which is we have to do things for customers so they have more confidence in us as a business. We are constantly trying to transform. Every business is actually trying to transform themselves into a tech company, right? And there is always ideas of build versus buy that is always hanging out there. We absolutely have to have a customer-centric focus to succeed in any business. And while doing so, we always look to stay compliant with our local laws or any laws, especially in Asia, because the businesses typically tend to be in multiple countries. So you have to comply by the laws of various countries, right? And last but not the least, and especially in these testing times, when we are trying to get back into the business again after our, say, post-COVID time, adapting to the market conditions. This is an extremely important trait that we have to keep in mind. So why, at the beginning, right, you would ask, like, why am I here? Why am I listening to this Yugabyte presentation? Well, let me take you through a very short story, okay? It starts all the way at the Big Bang. So about 14 million years ago, Big Bang happened. 14 billion years ago, Big Bang happened. And like through ages, like humanity flourished after 14 billion years. And then at some point, there was an RDBMS, right? Everybody used it. Every application that you saw was backed by an RDBMS. Even things that were built way back, maybe in 90s, they were always backed by a database of sort, right? And you would have all these marquee names, which were part of that ecosystem, right? So one thing that was always part of life, and it is in some cases, right, today as well, you would have manual failovers, you would have upgrades and maintenances, and worst of all, network partitions and data center failures. Now, these things were tough. They made the IT engineers, whether you're in operations or a developer, it always made your life miserable, right? Why? We ask, why was that the case, or why is that the case today? Typically, when you're talking about an RDBMS, it's a single node database, right? It is mostly sufficient. As your need sort of grows, you just get a bigger and bigger and bigger box, like you add more CPU, memory, and disk to it, right? But the human states have sort of, evolved in a very exponential way in last sort of 200 years, I guess. At first, in the beginning, when we were in these stages, you get food, you're happy. You don't get food, you're angry. But today, we have a very different problem. Ever since Steve Jobs put an iPhone or an iPad in our hands, the moment a service is slow, you're angry, and the moment something is down, you get angry. Something is like something is not straightforward, you're angry. And worst of all, people have so many avenues to react about it, right? They will go tweet about it. They will make a TikTok about it. They'll put a Insta message for it. They will make a Snapchat out of it. And it puts a very bad reputation for the business, right? So when we are looking at the applications which are sort of supporting the customers today, right? We saw like static applications in the 80s and 90s. And then in the mid 90s, we started actually looking at more database-based applications. Then there were fat client-based applications, ERPs and CRMs of sorts. Then like sometime in the 2000s, when the whole mobile era sort of bursted into the scene, right? The expectations of the consumers have changed. They want absolutely highly available applications. They want absolutely scalable experience. If I am using your application and 300 other friends of mine are using the same application, I don't want to be queued, right? I just want the information now, right? So, and the thing is that you are just one click away from losing the customer these days, right? I mean, they will always find another vendor to sort of, provide them with the same set of information in a better user experience. So we sort of evolved into this whole modern microservices-based architecture to support the consumer behavior that has come into being. Now, typically, these modern microservices, they sort of adopted a multi-data model approach and high availability and scale as the mantra to sort of succeed. Now, what does this mean? So first of all, the data model that we deal with in modern applications, they're diverse, right? I mean, you have very diverse reads and write patterns. You could have simple sort of key-based lookups for data. You can have very complex joins that come into being. And then in case of writes, you could have a ton of data being written in span of seconds, or it could be really point changes, the transactional changes. And then you may have a need for actually integrating to the rest of your ecosystem through things like change notifications or change data capture, as we call it. So, and also the automatic expiry of older data sets. So these are all the sort of data patterns that are impacting the systems that we can actually leverage for supporting it. So when we start looking at this, a few options that sort of arise to back these microservices, right? One is a sharded SQL kind of a system. So let's have a look at the sharded SQL, right? Now here you're basically running multiple monolithic databases, but you are at the application level, you actually have the intelligence to go to one or the other. You have a separate write, separate read, and this was a pattern that sort of emerged out of protecting the database, right? Where you want to make sure that the database is not overloaded with connections. It's not overloaded with queries where you have row level locking, page level locking, or even table locks, right? I mean, these are common problems that all of us have seen who've been in the industry, right? And because of these very reasons, generally, large tech companies who all of us actually try to emulate today, right? They sort of avoid, right? So then what is the choice? Let's look at the other one, which is one SQL with multiple NoSQLs. So this is typically what we call as a polyglot persistence philosophy. So this is where you are using different type of data systems to support different needs, right? Because like the sharded option was not actually easy. It was super hard to sort of do. The sort of split from microservices to the database was not sort of appropriate, right? So let's have a look at what are the different type of data models that we are looking at broadly. So one, we are looking at relational data model, which is providing you with the table and foreign keys and all the goodnesses that we have come to being, right, in last probably four decades, right? And then you have semi-structured data. This is like JSON or XML kind of data. And then you have the entity relationship model kind of data, and then you have the object-oriented data models. Now, here, like you would have column-oriented databases or key value or document and things like these, right? And these sort of came into being in around 2008, and coincidentally, like that's around the same time when the whole mobile revolution sort of started. Android and iPhone were like in everybody's hands by then, right? So what we realized was that the SQL-based RDBMS had limitations, not in terms of consistency, but in terms of resiliency. They were not resilient in the sense that you would have a single point, single machine which would fail. They were not horizontally scalable, actually. Most of them still aren't, right? And then you would have a sort of a data strategy to start moving parts of that RDBMS data into some sort of NoSQL or a sharded SQL or some other type of persistent storage. Let's take an example of an e-commerce application, right? How it would look like in a polyglot persistence case. So these are very typical sort of data models or data areas that you would find in an e-commerce application. So here, for your user sessions, you would use Redis, because typically user sessions, you need very fast lookups, and they are mostly ephemeral data. They could be multi-level objects and things like those. So there's no relational model required in those cases. So you end up using something like a Redis, right? This is fine. Then you have some sort of financial data and reporting data where you are looking at more of asset transactions and referential integrity and complex queries and joins. Then you have some sort of analytics and logs, which are not really relational, but you really want them to be ingested very, very quickly, right? And these data sets can grow really large. So you need the ability to horizontally scale. So you potentially would use something like a Cassandra for that, right? And then, of course, like you have a product catalog, which is like you have a product, there are many varieties of that product. So maybe you end up using a database like MongoDB for storing that stuff, right? Because, I mean, the schema is like, it's a flexible schema. It's what we typically call as a schema on read kind of an option. So it becomes very easy to build against it. And of course, like when you're looking at some sort of shopping cart kind of capabilities, you want data consistency, scalability, and high availability. So you probably go for a system like React, right? So, and I already mentioned about the Redis part. Now, what happens is that as your microservices sort of grow, all these data systems that are underlying it, they also grow. Every microservice sort of ends up attracting a different data system. Now, for app developers, it's a major learning, a new learning that needs to be had. Like as an app developer, I need to know Redis, I need to know Cassandra, I need to know an RDBMS, I need to know React, I need to know to query all these things, right? And each of these tools have a very different way of retrieving and saving data, right? So it is quite challenging. For a build engineer, everything that you saw on that board, they need to automate deployment of that entire thing. And not just deployment, even the updates. And then you have the test automation engineers. They just have to learn about the nuances of each and every data systems that is underneath. And worst of all, for the operations team, upgrading, patching, TR, recovery, all those things come into being. And sometimes they could be very different for if you're running something on premises and on cloud. So the pains keep growing, right? It doesn't stop. And one thing that typically, you would see is cloud databases. They sort of help in some way, but the challenge is they don't actually fix the underlying problem. They are actually providing you with an RDBMS. They are providing you with a document store. They are providing you with all sorts of things. But whatever are the underlying issues that each of those data systems is posing, they don't really solve that, right? It's a faster provisioning. And it sort of adds a nuance, which is now you are actually only locked into a single sort of infra. And they can actually get expensive in longer run, especially in some cases where you have a per query cost model. You really cannot actually have a trajectory or a projection of costs. So going back to the same question, like the modern microservices, they require the multiple data models, right? And the whole HA and scaling, that makes the SQL hard, but it can actually be done, right? So let me sort of give you a third option, which is a distributed SQL. Now, what exactly is a distributed SQL? We take the goodness of the SQL, the transaction, the ACID compliance, the atomicity, durability, consistency, and idempotency of RDBMSs, the easy programming model, the SQL-based model of that. We add the resiliency of some of the NoSQL databases, the scalability, and the ability to geo-distribute your data. That, in essence, makes up your distributed SQL. So RDBMS with a distributed architecture and NoSQL with a SQL programming model. That, in essence, is distributed SQL. So if I look back at my same e-commerce example, what I see is I can practically replace each one of these things. Like my financial data and reporting, I can actually use distributed SQL. For my shopping cart, analytics, and activity logs, I can use distributed SQL. For my product catalog, I can use distributed SQL that supports some sort of flexible schema like JSON-B data type or things like those, right? For my user sessions also, I can actually use, because the fast data lookups, unstructured data, semi-structured data, I can use with a distributed SQL. For something like a recommendations engine, I can actually use something like a distributed SQL with a graph engine on top, right? So this, in essence, is what it would look like. So then the next question that you would say is, okay, given that distributed SQL is good, right? What should I actually look for next, right? And that's where I would actually like to introduce Yugabyte. So we are a distributed SQL database. We have the resiliency, scalability, and geo-distribution of a non-relational database, and consistency, familiarity, and security aspects of a relational database. It's 100% open source, multi-cloud, and a hybrid cloud solution. Now, one thing that the last 2 years that have taught us is it is very, very hard to actually live in times where your global sort of supply chain is interrupted. So you definitely need to look at options where you are not just able to leverage your own data center, your premises, but also the cloud capabilities, right, to augment your application delivery, right? And this is where we come in. And very specifically, Yugabyte DB is a SQL and a NoSQL kind of a database. We are 100% open source. So if you're trying to sort of figure out where we are in terms of the sort of SQL, NoSQL, and proprietary open source quadrant, that's we are in top right. We have 3 offerings. We have a fully managed SaaS-based offering that you can just go sign up and start using the database. We have a self-managed DBaaS offering, which is Yugabyte DB Anywhere, that you can install in your on-premises, in your own cloud accounts and everything, and have control of everything with like enterprise-grade automation and everything baked in. And then we have a 100% open source, fully featured, no different from something like a Yugabyte DB Anywhere distribution, which is open source that you can just like download and start using. It can run on Kubernetes, it can run on Docker, Linux, Mac. We run it all the time on our own machines. So if you're looking at Yugabyte DB, right, when you start looking at it, these are the key things that you would find very interesting. And some of our customers actually had a lot of success using them. So first of all, it has a very familiar sort of a programming model. So we are 100% compatible with PostgreSQL. So you can just start using Postgres, you can just start using Yugabyte DB as a drop-in replacement for a PostgreSQL. Now, PostgreSQL is actually an addition on top of the NSI SQL. So if you're already using things like, say, MySQL, and if you're not using any proprietary capabilities of any of the proprietary databases, you're pretty much at home. Like you do not expect much change in your application. In some cases, it's only a matter of changing the driver and you're good to go, right? And especially if you're using ORM technologies like JPA and in case of Node, like SQLize, or in case of Python, like Doctrine or something like that. It's transparent. The complete thing is transparent. And this actually gives you access to the advanced features that you have actually come to use, triggers, stored procedures, and security. Now, this actually allowed one of our customers to move their entire database from a DB2 to Yugabyte DB. This very capability. There is, of course, like you're able to actually scale the database as the need grows. So we have a retailer who's using Yugabyte DB. They're able to scale to handle their peak traffic on Black Fridays and Cyber Mondays very easily. And they can do like billions of operations per day with hundreds of terabytes of data, right? And the whole scaling part, you just provide that, okay, instead of 5, and I want to run about, say, 10 nodes, and all the sort of data rebalancing and everything, it happens automatically. The very nature of the distributed technology gives it the resiliency in the availability. So we are able to survive even availability zone failure for a cloud. And this does happen, right? We have had customers who survived a complete cloud outage for a particular region because they were able to serve the data from another region. That's how their system was architected. And of course, when we are doing even patches and upgrades, because we know that security vulnerabilities, they come out all the time. You cannot take down your application while a patching is in progress. You're able to do that live. And one of the most important things in modern times is the ability to geo-distribute your data. So have the data actually physically sit in a particular region, right? Still giving you a single logical view of the entire data, but physically being distributed is extremely useful. So one of our customers, Admiral, they are actually running their Yugabyte DB instance across 5 regions, and they are able to deliver with like a P99 of 3 milliseconds with for reads. This is for data that is physically, say, sitting in Europe for European customers and in US and in APJ and things like those. So just sort of double clicking on that same point, right? The SQL capabilities of Yugabyte DB gives you the ability to use the advanced SQL capabilities. It gives you the ability to have a continuously available system with extremely low RTO of about 3 seconds and a 0 RPO. So absolutely no data loss. And it can scale really fast, and the numbers are in front, right? And then, of course, the geo distribution part, I cannot emphasize it enough, especially with the likes of the compliance rules that are existing in the world today, like GDPR. This eliminates the stress of doing all this thing from at the application level and putting it on the database itself. So we have a philosophy at Yugabyte, like show, don't tell, right? So I've been at it for about 20 minutes, I guess, now. And let me show you a very interesting demo that sort of highlights what I'm talking about. So this is about a retailer, a fictional retailer. Let's call it the largest river. They're a global retail chain, right? And they have a monolithic application that they want to actually make into microservices. So they've created a couple of microservices. And the other thing is they want to be able to scale out of their legacy database and have a more scalable and distributed and a cloud native database. Now, very specifically, the challenges that they have is they want to simplify their product catalog management. So whenever they make changes in their product catalog, they want that all their retail stores, right, they actually get those catalog updates instantaneously, right? And they want to have a centralized or aggregated sort of sale transaction near real time. So all the stores, when they are actually making the sale, the orders, they want to be able to actually bring it back and have it aggregated and have it analyzed and maybe use a different way of fulfilling the order, right? And of course, manage the inventory at the stores, which are sort of running at an edge, right? So with that background, this is what their sort of setup looks like. They have a central hub, which is in their data center. They have a retail store, which is on a far edge, and they have a near cloud or on cloud kind of a online store, which is their e-commerce front, right? And all the orders, they have to flow back to the central hub, and all the catalog updates have to go to the stores, right? So with that background, let me just quickly show you this demo. It's a recorded demo because it takes far too long to set these up quickly.
Okay, so here we're going to do a demo and a show don't tell type thing of some of the retail experiences that we talked about. Well, we're going to talk about two specific retail experiences. And of course, our retail app right now is a microservices-oriented app. There's an API gateway, and we're going to talk about three specific microservices. The product service.
Sir, can you increase the volume?
The point of sale system.
The volume of the audio.
Which allows you to add the shopping cart, and the checkout service that actually
is that better?
Now,
yeah. Can you max that?
Approximation, but there's a product inventory and a product, but it's about two types of tables. The product.
Yeah,
sorry.
Better.
Give me 1 second. I think I made a mistake. Share, optimize, and share some. And let me restart the demo because I forgot to. Yeah.
Okay, so here we're going to do a demo.
Is that better?
A show don't tell
much better
of some of the retail experiences that we talked about. Well, we're going to talk about two specific retail experiences. And of course, our retail app right now is a microservices oriented app. There's an API gateway, and we're going to talk about three specific microservices: the product service that deals with displaying all the products, the point of sale system or the shopping cart service, which allows you to add to shopping cart, and the checkout service that actually fulfills the order. Now, it really deals just with two types of tables. I mean, it's an approximation, but there's a product inventory and a product, but it's about two types of tables: the product catalog and the orders table, right? What we're going to do is one experience we're going to focus on is for the retailer trying to drop price from the cloud to the entire fleet of stores across the entire country, right? And this involves one-to-many replication. You make the change in the cloud, it needs to propagate all the way. The second experience we're going to focus on is that of the shopper. The shopper is going to place an order in the store, asking the retailer to ship it directly to their home. So all of the shoppers are placing all of these orders across different stores. These need to be aggregated in the cloud in order for the retailer to have a bird's eye view of what orders need to be fulfilled. And this is many-to-one replication. There are many stores that has to replicate to a single cloud application. So let's take a look at this demo. Okay, first we got to understand the setup. The cloud portion of the e-commerce store is running on a managed database on AWS. I mean, remember, we started our mythical retail startup company on AWS. And each of the stores, we're going to talk about two stores. Of course, it's a simplification. There can be hundreds of stores here, but let's take two stores. And let's say store one, that's what we're going to call it. And I'm going to switch to my terminal in a second. So we're going to color code these things. The cloud application is color coded blue and stores are color coded green. So store one is located far away from any cloud region in a remote location. And because it's not near any cloud region, it's running on a private data center that's living in the store. And naturally, Kubernetes is a really nifty way to do this. So it's going to be running on Kubernetes. Specifically for this demo, it's running on an Anthos cluster. And the second store is actually located near a Google Cloud region. And it's a fully managed, again, instance of Yugabyte DB. Okay, with that set up, how are we going to accomplish scenario one? Well, in order to broadcast pricing changes to all the stores instantaneously, and remember, these stores could get partitioned, so you still want them to work in a completely independent manner. We'll choose to use asynchronous replication of data, right? So the price markdown comes, let's say there's an item that's $158.74. We're going to mark it down to $100. Why not? Give the discount, see how many people buy it. Well, the minute you do this on the cloud application, on this particular microservice, it's going to change the price on a particular table. That table is going to replicate it all the way to store one and store two. And store one and store two's price is going to change from $158.74 to $100 even, right? And it's going to happen across the entire fleet of stores almost instantaneously. Then the second thing we'll do is a user, because of the dropped price, now comes and buys this item, right? So what's going to happen? Well, the first user is going to come to store one and place an order. And the second user is going to come to store two and place an order. All of these get pushed up to the cloud, and the cloud gets a global list of orders in order to fulfill. Okay, so that's what we're going to take a look at. All right, let's jump right into it. Well, first, what I have here is I have a React app, a UI-based app that is connected to store one, right? And this is the online version of that store, because the physical version is far more inconvenient to demo. And we're going to be ordering something for the part two of our demo from here. Now, before we jump into this, let's go quickly to take a look at our setup. Now, if you folks can see, I have 3 terminals, right? Each of which is connected to a database. Terminal 1 is coded blue and is called cloud and is a connection to the database that's running in the cloud. Store 1 is coded green and is connected to the first store, which is a pretty remote store. And store 2 is connected to the second store, which is actually the local, like this is the one that's closer to one of the cloud regions. All right. So what are we going to do first? Well, the first thing we're going to do is we're going to update the price of a random item. Okay. So let's first look at the prices. Well, I just picked 4 random items, right? I picked the SKU numbers of 4 random items. If you look at this query, it selects title, price, quantity, some stuff. It selects the actual inventory, and it does a join across the products in the product inventory table, and it prints them out. So what we notice is we have Cassell Standard Latin Dictionary, thumb indexed, selling for $158.74. But one point here, just to note, is that I personally would never buy a dictionary at $158.74. But if a lot of people are buying it, it kind of explains why the largest river is actually growing so fast. But anyway, that detail aside, and by the way, somebody remind me never to do a retail startup. But all of that stuff aside, let's go run the same command on a couple of other stores. So on the cloud, and this is on a store, right, where it's the same price, it's $158, and there's 132 items in the quantity. And there's about 338 in total quantity across this store. Okay, now we want to drop the price of this item to $100. Okay, let's get on with that. So I'm on the cloud terminal, and I'm going to change the price of this item. So this SKU is that, right, which represents Cassell Standard Latin Dictionary, to $100 on the cloud side. Okay. Having done that, let's check the prices, and we see that the price is actually reflected at $100. Now, let me go to store 1, and if you remember, this price was $158. I go ahead and do the same thing, and I see that the price has dropped to $100. If I go to store 2, once again, it was $158, and if I run this, it's now $100 as well. So great. As a retailer, we just updated and dropped the price of Cassell's Standard Latin Dictionary to $100. Of course, everybody would use Google today to figure out whatever the meaning of a word is, but we'll still stick to the thing that everybody wants to buy, Cassell's Standard Latin Dictionary. The only thing that was stopping them was the price being $158. Okay, now that we're at $100, well, let's go and take a look at placing an order through one of the storefronts. Well, the first thing that we'll do is let's look at all the recent orders that we've placed across the board. Well, if I run a command that looks at the recent orders and prints them in JSON format in the cloud, it shows there's no orders. If I go run the same thing on store 1, it shows no orders. And if I'm going to do the same thing on store 2, and there's no orders as well. So there are no outstanding orders in the system. Now, I'm going to go to the UI, because why not? And conveniently, there's Cassell's Latin dictionary, and that's the hot selling book that everybody wants to buy. If you guys don't have it, you should get yourselves one. But anyways, I'm going to get myself one. I'm going to add this to the cart. And I see that this is there in the cart, right? And I'm going to check out this bad boy. Okay. So I just ordered by connecting to store number 1, the Cassell's dictionary. And what we expect to happen. So what we said was users can go into the bookstore, into the actual physical store. They can browse it. They looked at the actual book and now they place the order, right? And we're just doing it online, but they go talk to the storekeeper and they say, I want this book shipped home. All right, so let's go back, right? And let's rerun this query to see what orders there are. Well, and there you have it. There is actually an order for Cassell's Standard Latin Dictionary thumb indexed in store 1. If I run the same query again on store 2, well, nobody's ordered from store 2, so there's nothing there. And if I go back, and the other thing to note in store 1 is if I run the inventory on store 1, it's going to say like the quantity was 132 on Cassell, it's dropped down to 131 because we've started fulfilling something, right? Now, if I go into the cloud and I want to see, you know, show me all the recent orders that have been shipped from any of my stores, well, there you have it. The hot selling Cassell Standard Latin Dictionary, right? It shows up right away. And so this can do a lot of things. Well, you can fulfill this from the cloud if the location of the user, if the home location of the user is really far away, because users can be buying stuff when they're visiting places. You could actually use this for analytics to backfill Cassell Standard Dictionary. This could be useful for a number of things, as we talked about. So that's the demo in short. The point here is, you know, we are reaching a stage of off-cloud and on-cloud type of experiences that have to blend, right? And there's a variety of different types of replication required, and we've used asynchronous replication in this case. But you know, depending on the use case and the exact scenarios, we'd have to pick and choose the right tool.
Right, that's for the demo. And this is every time so much useful, right? One thing that typically, like as a developer, right, we've known SQL and it's been around for like, I guess, 3 or 4-ish decades. So we tend to have this notion that because it's old, then it's not useful. I wanted to sort of draw your attention to the SQL part of the distributed SQL. You just saw how distributed part of the equation is useful. And this part of the presentation is heavily influenced by my kids. You can see the glimpse of it in this, right? So first thing is that SQL is everywhere. If you open a spreadsheet and if you just put a simple query and like do it, you look at some of the event-oriented systems today. Kafka, they have SQL in it, right? In data sciences, people are actually using SQL for working with data frames and things like those. In .NET, you have a SQL-ish language in the language itself, right? So it's everywhere. And then if you start sort of comparing it with some of the other ways of working with data, right? So for example, over here, you have a Java code, right? Which I have been a Java developer all my life, right? I have done things this way. But this, and even the more functional, the newer approach, the functional approach of doing things, and like, you know, some magical JSON-oriented query versus a simple, concise English-like query that, you know, sort of gives you a lot of joy when you're doing it, right? And one thing is that, you know, with SQL, we were obviously, you know, we are used to the things like you have tables with like basic data types and all, but you have these really interesting data types called JSON-B, which is actually allowing you to put documents of JSON into the database. And then they're not just text fields. You can actually query things. You saw that in the demo, that we were able to look at the orders and pretty print them. You can even select things from inside the JSON object within your query. You don't have to bring the entire data back. You can actually process it on the database itself. And it has definitely evolved a lot. You have ORM technologies, which make it very, very simple for you to do it in an object-oriented way. You have technologies like Flyway, which actually is the distributed SQL, which gives you a complete resiliency of the data. So how would your journey look like, right? I mean, everybody has a different sort of a pace, right, of going on. I have a couple of pointers here. So one is, how do you transform your data platform? One, when you're looking at your existing application, which is sort of a monolithic legacy architecture, right? When you want to modernize it, you augment it with a distributed database. Now, with the database, you may have two options. You have a monolithic database and you actually refactor it into separate databases, right? Or you have a monolithic database, and with minimal schema changes, you can just have the distributed database while not changing much on the top layers. You can choose depending on the sort of need actually that is there for you, the business outcome that you're trying to achieve. You can pick and choose one of these two. And then from a application perspective, you've seen monolithic application that work with a single node database. They break up into microservices. When you want to actually open up a new geo or scale out, you literally create another silo. With Yugabyte DB, there is no data silo. The data is always sort of connected and replicated across the clusters, right? So I'm going to leave you with our little pointers here. So feel free to contact us through VST, directly go to Yugabyte University to know more about it. And frankly, just go ahead and try it yourself.